Hello everyone. So from the first video onwards, we were seeing the DC analysis of CMOS inverter. First we applied the pulse input, then we applied the ramp input, then we interchanged CMOS and NMOS. All these things we do. Now we will see the small signal analysis, small signal AC analysis. You can say small signal AC analysis. Okay. So now we have to see the small signal AC analysis. So first thing we will find is that what will be the voltage gain. Voltage gain. Try writing the voltage gain by your own. You can do it now. Okay, so first let us draw the small signal model. This will be shorted, this will be shorted, this will be shorted, and this will also be shorted. This is because this is a supply, right? And this VS, why I am shorting this, sorry, this is VS, this is VS, and this is VS, and here we have R not connected, R not 1, let us call it as M2 and M1. So this is R not 2 and this is R not 1. Okay, so this is the thing, right? Now we have two VS voltage, kind of we have two VS voltage, although it is a one supply only. So kind of we have two VS voltage. So we can apply superposition theorem, right? So applying superposition. Applying superposition, what will be your V naught? Your V naught would be V naught by Vs, we will write. Gain equals to V naught by Vs would be, look, first we will consider this one to be short circuited and this one in action. NMOS is in action. Okay, if the NMOS is in action, this is short circuited, so here VSG is 0, right? VSG is 0 volt. If this is 0 volt, then there will be no current, this will be open circuited, right? If this is open circuited, now from V0 to ground we have R01 and from V0 to ground we have R02. So R01 and R02 comes in parallel. So this side is open circuited and this R01 is parallel to R02. So the upper side is gone now. Okay. So now you need to see the lower side only. So what will be the gain for it? This is a common source amplifier, and what is the gain? Minus GM1 into R01 parallel with R02, right? Now in the next stage what happens is that, oh damn, we will write it again. Let us erase all these things. You understood, right? VSG is 0, VS is short circuited, VSG is 0. So if VSG is 0, that will be open circuited, R01 and R02 will come in parallel. So your gain would simply become minus GM1 R01 parallel with R02. Okay, so minus GM1 R01 parallel with R02. Now talking about this one, and this is shorted. If this is shorted, this would be gone now because here VGS is 0. So this will be open circuited at 0 current. So this will be open circuited, and this R01 and R02 will come in parallel to each other, right? Because V0 to ground we have R01 and R02. So what will this become? Again, this is the common source amplifier, but this is the case of PMOS, right? In case of PMOS, what will be the current flowing? In this direction, we will have GMVS current, right? Because this is 0, this is VS. So in case of PMOS, what is the current? GMVSG. What is the value of VSG now? VSG is minus VS. So GMVSG current is in this direction, GMVSG. What is the value of VSG now? Minus VS. So GM into VS current is flowing in opposite direction. So what will be the V0 value here? In this direction, if the current is flowing, so V0 would be minus GM into VS into resistance R01 parallel with R02. So what is the gain? Minus GM2 into R01 parallel with R02. Did you understand it? Just a simple analysis, nothing else. Again, in case of PMOS as well, it is becoming as a common source amplifier only. Okay. If this is shorted, this is gone. R01 comes in parallel with R02. This is source is common, and we are collecting output at drain. The source is common. In case of PMOS, the source is common and we are collecting output at the drain terminal. So what is happening there? So this is simply a common source amplifier. And what is the gain for common source amplifier? Simply that's same gain. Or I have shown you the derivation as well. The current is GMVS. The current is GMVS in this direction. So your V0 would be minus GMVS into R01 parallel with R02. So this will basically be minus GM2 R01 parallel with R02. Okay. So addition of both. So basically, what is your gain? Gain is minus GM1 plus GM2 into R01 parallel with R02. Okay. Did you get it? Minus sign is common. GM1 plus GM2 into R01 plus R02. So this provides a gain of this much. Okay. So this is the voltage gain. Finding the output resistance. Now you should write it by your own. What is the output resistance? And don't do it wrong this time. Okay. You should be able to write it down correctly. So what will be the output impedance? This VS, everything will be shorted because these are the input source. So this will be shorted. So this will be gone. This MOSFET will completely be gone. This MOSFET will completely be gone. So what will remain? R01 parallel with R02. So it would be R01 parallel with R02. Right? Did you understand it? VS is gone. VSG is gone. VGS is gone. Open circuited. From V0 to ground, what do we see? R01 and R02. So it is R01 parallel with R02. What is input resistance? If input current is 0, then what will be the input resistance? It is infinity, because the input current, this is the input current, this is the input current, these are 0 only, right? So it would be infinity. And what is the current gain? Current gain, I out by I in. It would also be infinity because the input current is 0 only, right? The input current is 0 only. Okay. So this is the small signal analysis of CMOS inverter. Okay. We will see a few more questions now. Okay. Thank you.